Hello and welcome to video 26 in my Rigging in Maya series. Over the last few videos we got a little distracted with some scripting, but I hope they helped to introduce you to Python and show you how useful even some basic knowledge is. Some of you may be happy to know though that we are back to doing things manually, and in this video we are finally going to build the ribbons which our driver joints will influence. The idea is that using ribbons as a base will make the rig more flexible and open up more options for the animator. Now before we get started, I just wanted to mention that you can download all the source files for this and all my other courses from my QBrush, Coffee, Gumroad and ArtStation pages. You can find links on the screen and in the description below. I also wanted to tell you about the antCGi Club. Joining the club is a way for you to help support the future of this channel, as it allows me to dedicate more time to creating new content just for you, and it also allows me to keep it all free. But that's not all. You can also earn yourself exclusive rewards. These include all the course assets, models, rigs and custom made scripts, as well as access to the members only area of the antCGi Club Discord server. You can also claim a discount on all antCGi merchandise. There are two ways you can join. The first is to simply click the join button below this video and become a member of this YouTube channel. The second is to head over to my Patreon page and support me there. Alternatively, you can visit the link on the screen or in the description below to find out more. Okay, so here we have the current rig. And if you want to follow along, you can just open the file associated with this video. If you remember, we automatically rigged the joints using the script we created previously. If I click this button, it opens the UI, and you can see how this was built in my recent CG tips video. This rigged the front and rear legs and also built the roll and stretchy joints too. So now it's ready to drive the ribbon. The only difference between this and the last file you worked with is that the driver joints are no longer driving the model. Which is fine because it was only temporarily skinned. First, let's hide the model. What we want is a ribbon which will follow these joints, and then the follicles, which are part of the ribbon, will drive the model. As mentioned earlier in the series, I'm not going to demonstrate how to create the ribbons from scratch. If you would like to see those, please refer back to my video on ribbons. Instead, I'm going to give myself a head start and use my ribbon creation tool. This will generate all kinds of ribbons for you, all automatically. And it's had a few updates to coincide with this video. Again, there is a full demonstration of this tool in action in my CG tips video. You can also download it from any of my online stores, and antCGi Club members can claim it as a reward. I'm going to start by updating the name to rear because we will be focusing on the rear legs first. I'm also going to disable these options here. Those are some of the new tools I've added, so I will go over those in more detail later. I added the ability for the tool to remember the previous settings. That's why I'm having to go in and change them, because these are the settings I used when I was setting this up previously. We want to create the basic controls, and a global scale of 5 should be fine. I want there to be 2 joints between each main one, so mid joints is fine set at 2. We need joint orient to match the orientation of the joints. So we can see that X is pointing down the joint, so X is fine. It's important that the ribbon joint orientation matches the leg joints. Reset end joint is active because our ankle joints are orientated to match the world axis. As this is a dog leg, we need 3 joint limb checked too. I also want the knee areas of the ribbon to be more angular, so I'm going to add creases as well. Okay, let's build this and see what we get. So, there we have our basic ribbon. Again, if you want to build this manually, you can follow my ribbon tutorial. We have the control joints and the follicles. All the main controls are up here. So, because these were generated, we need to go in now and rename them all so they match the joints. Don't worry, I'll speed up this part of the video for you. Okay, done. So we can now move these controls and it deforms the ribbon. As we do this, the follicle joints follow the surface and remain perpendicular to it. If you imagine these then deforming the model, you can see how much added flexibility this will give us and the animators. Now this is ideal for more fluid areas of the rig, because as it deforms you get nice smooth curves. For the dog leg, we want it to be more angular, so we need to add in some more joints to help control this aspect. This is also where the creases come into play. Let's hide everything so we can focus on the ribbon. What we need to do is create two new joints. One here and another up here. Let's duplicate the rear metacarpus control joint and parent that back to the joint we just copied. Let's update the name, so change the end to angle. Duplicate that and parent it to the angle joint. Call that angle tip and then snap it to the control joint above it. So that's the metatarsus control joint. Let's update the radius so we can see it a little better. And remove that number 1 from the name. What we need this to do is rotate as the control moves, so it's always pointing towards it. This will give us an angle down here, so we can use the main angle joint and the control joint to deform the ribbon and give us a nice clean angle as it bends. Now this might not be as useful down here because we're at the end of the ribbon, but it will be further up. We now need to make these joints follow this control. And I'm not going to use any fancy nodes. Instead we'll use a simple IK handle. All we want is a single chain solver. I can hold down Shift and that will allow me to select the start and end joints in the outliner. Let's rename that before we move on. As you can see, as the IK handle moves, the joints rotate to follow it. Now the easiest thing to do would be to parent the IK handle to the control joint, so it follows as the control moves. That works as we move the control. But if we rotate it, the joint chain rotates too, which we don't want because this will twist the ribbon. So that won't work. Let's unparent that. Luckily, because of how this is constructed, we can simply use a direct connection, which is much cleaner than trying a point constraint. The IK handle is the same distance away as the control joint, so the transform attributes are the same. So all we need to do is connect the translate attributes from the control joint to the translate attributes on the IK handle. We can move the control now and the joint follows. And if we twist the control, the joints stay static. Perfect. Okay, let's move up and add the next section. And this is the same as before. First, let's duplicate the metatarsus control joint and parent that back to the metatarsus control joint. Let's rename it to angle now and duplicate that, parenting the copy to the original. And call that angle tip. We'll adjust the radius again to 1.5 and now snap the angle tip joint to the next control joint along the ribbon. Okay, good. That will pivot nicely. Next, we create a single chain solver IK handle. Going from the angle joint to the angle tip joint. Finally, we connect the translate attributes from the fibula control joint to the IK handle. Let's update that name before we move on. There we go, that works. Okay, last section. So, duplicate the fibula control joint and move the copy back under it. Rename it to angle and copy that. Again, move it under the angle joint and rename it to angle tip. Adjust the radius. This is purely a cosmetic step. It just means I can see the joints and they don't completely overlap. Okay, snap the angle tip joint to the femur control joint. And create another IK handle. Let's connect those translate attributes so it follows the femur control joint. There we go, and we don't get that twist. Rename the IK handle to keep things organised. Okay, that's the extra joints added, so now we need to make sure they affect the ribbon too. So we need to add them to the existing skin cluster. We only need the angle joints, so select those. And then the ribbon. And go to skin. Actually, I'll move this up so you can see. So skin, edit influences, add influence. We can just use the default settings because we haven't painted any weights yet. And click add. We can see those are now influencing the ribbon. Now don't worry, we're going to paint all the weights later in the video, so these default weights will be changed. You may find that you don't actually need the first section of angle joints because those are at the start of the ribbon. But what I would do is I'd experiment with how you want that area to deform and then decide later. You can always delete the joints if you don't need them. Okay, that's this stage done. What we need to do now is look at adding more controls between the main ones. These will be the tween controls and add more flexibility to the limbs. We need another joint for this control, so let's copy one of the existing ones. Doing this will make sure the orientations are kept the same. Let's add tween into the name. We want this to be between these joints, so exactly halfway. To help us, we can select the joints either side and then the tween joint and use a point constraint. Maintain offset needs to be disabled so the joint will actually move. There, it did move slightly, but it's now in the right position. We can delete the point constraint now because we no longer need it. Let's copy that joint and move it down for the next section. And rename this one to fibula tween. We need one more joint. Move this one down and call this metatarsus tween. Okay, let's use temporary point constraints again to make sure these are all in the right place. And update this one. Okay, good. We need to make sure we delete those point constraint nodes too. We now need to create some groups. First, add 3 empty groups. and rename these to Tween offset groups so they match the name of the joints. OK, now copy those groups and change the name to aim on the end of each instead of offset, and then parent it to the offset group. So femur tween aim goes under femur tween offset. Fibula tween aim is parented to fibula tween offset, and metatarsus tween aim is parented to metatarsus tween offset. Now we need a control, so let's copy this one for now. I'll move it out of the hierarchy. Here will do. And I'll zero out the transforms to see what we have. OK, so first let's orient it so it matches the others. It would be better if this control looked different to the others too, so the animators can easily spot which is a normal control and which is a tween control. Actually, let's isolate it so we can focus on it for a minute. I'll scale this side and this one, just adjust it a little more. OK, that will do. Let's also change its colour. Blue will do. OK, that looks very different now. Let's freeze the transforms to get rid of the 90 on the Z rotation. We also need to rename this control. Just adding tween will do. Let's now duplicate it twice and update the names of each copy. So femur and fibula. Oops, remove that M. Now we parent each control to the aim groups. So that's those set up. We just need to move them now so they are where the tween joints are. We can just use the Match Transformations tool to do this. So select the offset group and the tween joint and match all transforms. Next one, offset group first, then the joint and match. Next one, so select the offset group and the tween joint and match all transforms. OK, now adjust the orientations again. I know we are just adding the 90 we removed earlier. Freeze the transforms to clean those up. So that's the main controls ready to go. Before we move on, let's add the tween joints to the ribbon's skin cluster, just like we did earlier with the angle joints. So select the joints and then the ribbon, and go to Skin, Edit Influence, Add Influence. Now we can adjust the tween joints and the ribbon deforms. So we know that worked. The next step is to make the controls drive the tween joints. To do this, we simply use a parent constraint. So select the control and then the joint and go to Constrain Parent. Make sure Maintain Offset is enabled. Repeat that for the other joints. Now there are a couple of reasons why we use a parent constraint instead of just parenting the joints to the controls. The first is that I like to keep my joints separate where possible, to keep the rig flexible. The second is that later in the series we will want to add more scaling options into the rig, and if we had the joint parented to the control, this would restrict how we implement it. For example, if we scaled the control, the joint would scale too, which would deform the ribbon. But we may want the scale attributes to affect another part of the rig, so keeping the joint separate means we can do this without affecting the ribbon. OK, the controls now move the joints. Most of the time, the tween controls will be hidden because the main animation will be done with the main controls. With this being the case, we need the tween controls to follow the main controls so the limb deforms correctly. That way, they are ready when the animator needs them. So let's make the tween controls stay between the others. To do this, we need to treat the translation and rotation attributes separately. First, the easy part. We can use a point constraint to make sure the control's position is always between the other controls. Select the femur and fibula controls. Now add the femur tween offset group. We use the offset group because we need to leave the actual control clear of any influences. Close this. Now add a point constraint. Making sure maintain offset is disabled. If we now move the femur control, the tween control follows, but stays between it and the fibula control. Now it's not rotating yet, but we will come to that. Let's update the other tween controls now, point constraining the offset groups to the controls on the other side. That's done. And now the metatarsus tween offset group. OK, done. As you can see, when we move the main controls, the tween controls follow. We are still able to move the tween controls too when needed. So that's the position updated. Now we need to look at the orientation. Ideally, we need the tween controls to orient towards one of the others, so it maintains a nice straight line in the ribbon. This is where we use the aim groups we created earlier. What we want to do is tell those groups to always point towards the next joint. So in this case, the fibula control joint. This will level out the tween control for us. To do this, we will use an aim constraint. Let's reset this. OK. So we need the aim group to point at the fibula control joint. The aim vector is 1 in the x-axis, which is fine because the group will be pointing down the x-axis. We also need to update the up vector too, so it's x. To keep things steady, we will change world up vector to object rotation up. This will make it use a specific object's orientation. What we can do is use the fibula control joint as the world up object, so the same one we are aiming at. I'll paste the name here. OK, ready to go. Select the aim group. Actually, I need the femur tween aim group. And then the joint we want to aim at. So that's the fibula control joint. And apply. I selected them the wrong way around. The object which is being constrained needs to be selected last. Rookie mistake. That's better. Now as I move the fibula control, you see the tween control stays orientated towards it. This will help to maintain the shape of the ribbon as the main controls are being animated. OK, let's do the next one. So this time we want to point to the metatarsus control joint. Let's copy the name and update the world up object. That's all we need to change. So select the control joint first this time, and then the fibula tween aim group, and apply. That's another one done. On to the last one, the metatarsus tween control. So this time we are aiming at the rear metatarsus control joint. Let's copy its name and update the world up object attribute. Select the joint and then the aim group and apply. We use the aim group because the rotations are at 0. The offset group has values applied, and yes, we could still use a constraint on it, but you would end up with it flipping at certain points. Where possible, use constraints with minimal offsets. That's done. OK, so we have the ribbon pretty much set up now. Let's bring back the main rig and get it connected. What we need is for the main controls to be where the joints in the leg are. Then what we will do is simply constrain the ribbon controls to the leg joints. What we need to remember though is we want the ribbon to follow the roll joints, so we get the correct movement in the hip and the ankle areas. First, let's get the controls in the correct position. We can use the match transformation tools again to do this. Select the femur offset group, and then the femur roll joint, and match all transforms. Next, the femur joint. Doesn't actually matter if it's the IK joints, we just want the position and orientation information. And the fibula offset group, and match. Oops, selected them the wrong way around. Undo that. So, select the group first, and then the joint. That's better. Now the metatarsus. And finally, the rear metacarpus. I've selected the roll joint, but again, at this stage, it doesn't really matter. Which joint you select is more important later when we come to use the constraints. So those are all in position now, but the ribbon looks very wrong. This is because we now need to go in and spend some time doing everyone's favourite job, painting weights. Don't worry though, this doesn't take long at all. Okay, let's open up the Paint Skin Weights tool. So at the bottom I'm going to adjust the weights so the ribbon is skinned to the main control joint, not the angle joint. I'm doing this so the bottom of the ankle follows the roll joint correctly. If I skin it to the angle joint here, it will ignore the roll joint. This is why I said earlier that you may not need this lower section of the angle joints. So it's up to you and what your rig needs to do. I may delete these later, but we'll see what happens as we work on the paw. All we're going to do is use the replace paint operation and make sure opacity and value are both set to 1. I'm just going to paint along the bottom. So make sure you cover the whole area because there are some CVs up here. That's done. Now up to the next joint, which is the first tween joint. All I want to do here is make sure these two isoparms are fully influenced by this joint. Now we have the first angle joint. To make things easier, I'm just going to fill this whole area in. If it makes things easier for you to work with, you can just press 1, which will drop the smoothness of the ribbon down so you can see the sections a little clearer. So this angle joint wants to affect this area above it here. The control joint needs to influence the section below, and it's these two which will give us that nice angle that we want. The control joint just wants to affect this area. That's the lower section done. I told you it wouldn't take long. We can quickly test it. So you can see the follicles moving as it deforms. Okay, next section. Let's work on the tween joints and fill in those middle isoparms. Maya does get a bit funny when displaying things like this, so don't worry if you can't see things or if you get a red area like above. You see, it's weighted to the tween joint, but it's still black. You do love Maya's little quirks. Now do the same with the next angle joint and fully weight this area. That's affecting this area. So let's adjust the control joint to fix the area below. That's better. Okay, final section. Tween joint first. You see, Maya is teasing me now by flashing the correct colours. And finally, the last control joint. Okay, that's looking a lot better. Let's switch smoothing back on. So select and press 3. I can see this area needs a tweak. That's better. Okay, let's bring back the controls. So the final step, on this limb anyway, is to connect it to the main driver skeleton. Let's bring up the joints in the outliner. As mentioned, the upper control needs to be driven by the roll joint here. So we select that and the femur offset group, and then use a parent constraint to constrain the group to the roll joint. We will turn off maintain offset 2 so it snaps to it. Next we want the fibula joint, and then the fibula control offset group, and constrain those. Now the metatarsus joint, and the control offset group. Finally, the rear metacarpus roll joint. Remember, it's the roll joint we need. And then select the control offset group. And constrain those. If I select the paw control, we can rotate it and the ribbon follows the roll joint, so it behaves as we wanted. So there we go. The ribbon now follows the driver skeleton, giving us more flexibility over how the leg animates. One thing I need to point out is that the follicles are entirely dependent on how the ribbon deforms. So you may want to spend more time playing with the weights to get a better deformation. I would, however, suggest coming back to that once the model is actually skinned, because you will get a better idea of how everything is working together. The idea is that the animator has basic control over the limb, but then they can go in and use these controls to adjust the leg if they need to. Now we're not quite finished with the ribbon, there is a lot more we can do with it, and I'm going to cover that in the next video. Speaking of which, there is one step I forgot to do at the start, and that was to make a duplicate of the actual ribbon. It's not a problem to do it now, but you will need one for the next stage. Okay, let's reset the leg. I just need to select the ribbon and open the skin cluster in the channel box. And set envelope to 0. This will put the ribbon back into its default pose. You can see all the little follicles following it. While it's here, I can quickly duplicate it and update the name to add def on the end. This is just to indicate it's a deformer version of the ribbon. Okay, let's turn the envelope back on. And we should unlock the deformer ribbon too. So that's ready for us to use in the next video. Okay, what we need to do now is look at creating the opposite leg. I can use the ribbon creation tool again. So let's change the name to right instead of left. As you can see, the right leg's x-axis is pointing the opposite way to the left. So we need to take that into account. All it means is we enable invert in the ribbon tool. But if you are building these from scratch, make sure you pay attention to the orientations of the joints. I could build the ribbon as it is, so we end up where we started before. But I can go one further. Let's undo this. With version 2.2 of the tool, I added the option to automatically create the tween and angle controls. Although looking at it now, I've actually called it tweak here. If I turn those on and build the ribbon again, we have all those controls done for us. Just saves us a lot of time. You can also see that the x-axis is pointing up, just like the right leg. So all we need to do now is snap the controls to the leg joints and then edit the weighting. Oh, we also need to update the names too. Because this is scripted, these are very generic. Okay, so what I'm going to do is I'm going to whip through and update all the other limbs now. So I'll be back in a minute. Okay, here we go. All the legs are done. Each limb is now driving its own ribbon, giving the animator maximum flexibility. I've also spent some time updating the hierarchy, as you can see. If you have access to the scene files, have a look through. All the controls are here. And under here we have our ribbons, plus the deformer ones we will need in the next video. The control joints are here, and the main systems are tucked away inside here. Here we can see all the follicles. One tip is to put all the follicle joints into a selection set and call it something like bind joints, like I have here. You should do this as you're building your rig, so you can quickly access the right joints when it comes to binding the skin. You can just right click and go to Select Set Members. I'll just bring back the model. Remember that it's primarily going to be the follicle joints that drive the model, so having a selection set simplifies the skinning process. Okay, so that's this stage complete. We are making some progress on the legs. They should be done after the next video, so we can then either move on to the spine or the paws. To be honest, I'm tempted to do the spine, head and neck next, just to keep all the ribbon work together. Also, would you like to see a spline-based spine or a ribbon-based one? Actually, I do have a system which uses both, so maybe I could do that. What do you all think? Let me know. Okay, well, we've come to the end of another video. Thanks so much for watching right to the end, and if you found this video useful, please hit that like button to show your support. While you're at it, you could also subscribe and enable notifications, so you're kept up to date with future videos and community posts. If you have any questions or suggestions, please post them in the comments below or contact me through the antCGi Club Twitter account, and I will try my best to reply. Alternatively, you could post them in the antCGi Club Discord server, where I spend more of my time. You can find an exclusive invitation to join in the description below. Remember that you can also join the antCGi Club to help support future videos, keep them free, and also earn yourself exclusive rewards. Alternatively, if you would just like to show your appreciation, why not treat me to a coffee at my coffee page? The link is on the screen now and in the description below. Thanks again, this is antCGi signing off, and I will see you on the next one.